Hey everyone, welcome back to another video here on DarkSec. I am Dark, and today we're going to be taking a look at the Learn Linux room on TryHackMe. This is a pretty long room. There are, let's find out how many tasks. There are 43 with a true ending. We're going to do all of them. I will have the video sliced up with timestamps. If you're on YouTube, you will see little timestamps around the actual play bar that you can hover over with your mouse and select what you need in case you're stuck. Otherwise, if you're not on YouTube, I do recommend switching over to it as it'll give you that option if it doesn't already. That being said, let's go ahead and jump in. So task 1, intro. This room is designed to teach you about Linux concepts and tools. Because of this room expects no prior knowledge. The only exception this room has is an eagerness to learn and a willingness to Google if you're stuck. This is key. Sometimes things are not 100% clear, and learning how to actually research things is really good skill to have. This room has a natural flow to it. However, if you're experienced in Linux and just want a refresher on a specific topic, you can jump around as need be. So we'll go ahead and mark that as completed, and I'm going to go ahead and deploy the VM as well while we move on. And we'll give it just a moment to start up, and while that's doing its thing, we're going to jump into task 2, methodology. After careful consideration, I've deemed the best way to go about this is to introduce various concepts in sections, with each section being more complex and requiring knowledge from the previous section. To enable the transition between between sections, I've split each section into different users in the VM. When you finish a section, you'll have to complete a challenge, and then you'll be able to move on to the next section. Perfect. Task 3, SSH, the introduction. SSH is the act of remotely accessing a machine. SSH allows you to run commands interactively on the remote machine. This is done through the use of a program on the target machine that allows the SSH client to interface with the target host. So what is this in English? We can log into remote machines and just get a little terminal like this. If this is your first time using a terminal, don't worry about it. It may look daunting at first. It may look, oh man, you're using something that's a really complex hacker tool. It's just a way to interface with the computer with not very much overhead, because the graphical part of this, so like our web browser here, all of these graphics that have to run, they take up a lot of memory. And you don't really need them once you know a little bit better what you're doing. You can do pretty much everything with this. Not to say that the graphics, the GUI, graphical user interface, that isn't useful. This just is a lot more convenient, and it's more convenient for accessing computers faster. One of the most common usage of a regular operating system is graphical, allowing you to see pictures, web browsers, file managers, etc. SSH works through the command line, meaning that anything done on the target machine will be done through a command prompt similar to this. So again, we have our example here. It may look intimidating at first, but you'll soon find out you can do much of the same functionality that you're able to do using graphical user interfaces. It is an invaluable tool, and you will be accessing this machine to learn and to do the challenges. Depending on the operating system, there are different ways of SSHing into the machine. This section will purely focus on the Windows way Putty, and after that we'll learn more about Linux commands and how they work, and we'll return to this section and learn about the Linux method. For the sake of the Windows method, I'm not actually going to show this off because it's pretty straightforward. We do have some pictures here. It's just nice to know about. I do recommend, if you're doing this room, you can kind of just fudge your way past this and just use a Linux console, which is what we're going to do because it's just easier. Alright, perfect. Let's jump into task 4, which is section 1, SSH, Putty, and SSH. So disclaimer, please do not use Putty if you are already on Linux, and that's what I had mentioned. You don't really have to worry about this. So you can download Putty here. Very straightforward, and I'll just open this up here. This is just Putty's website. You're going to want to grab the 64-bit installer here. Nice and easy. Just click through the installations, accept all the defaults, and you'll be just fine. It's a way that... well, newer versions of Windows do include an SSH client. It's actually part of PowerShell. If you're using something like Windows 7, it didn't actually have that, and we haven't had that in Windows for a very long time, even though it's widely regarded as the standard for accessing another machine. Once you've installed it, you can launch it, and you can see this window. It's a little bit intimidating at first, but the only real place that you need to know how to type things in is this host name or the IP address, and then the port number here. And then you can change whatever way you want to connect. In this case, we're only going to be using SSH, so we don't really have to worry about anything else. Scrolling down just a little bit, the field that we're most interested, again, it's going to be that host name or SSH. That is where you put the machine IP. Your machine IP here is going to be different. It's the one that's up here. And that's just so that we can connect in, and we're going to use our remote machine for learning a bunch of Linux tools like grep and other stuff. Very cool stuff, and it's stuff that you'll want to know going forward in your hacking career. This will be because, so when we're actually using Linux, the format of that command is username and then @ and then the host. This can either be the IP address or the host name, and we'll see a little bit more of that later on as we dive in. The user for this trial will be Shiba1, so the completed host name field should look like this. So we can see we have Shiba1 @ and then the IP address. Again, make sure you change this to the one that you have up here, otherwise it won't work. And then you can click OK or open right down here, and you should get a window that opens up like this. One thing to be aware of before you do this, you do need to be connected to the TryHackMe VPN, otherwise this won't actually work. If you are having some issues with connecting to the VPN, I would check out the welcome room, and I will grab it right here. The welcome room will teach you how to get all connected, and I think it's, there we go. It's just room and then hello, and you'll just have to join this. And I'll have another video up for getting connected with all this, but this will teach you how to get connected to the actual VPN. So jumping back in here, once you're already connected to the VPN, this is going to say, do you want to accept the fingerprint? With SSH, when you try to log in, it's going to interrogate the machine, and it's going to say, hey, what's your street address? Kind of. This is essentially like a mailing address for a machine. It's a little bit more than that, but it uniquely identifies a machine, and when you are logging in, your machine's going to say, hey, who are you? What's your IP and everything? And it's going to respond with this. This is useful to make sure that you don't have a different machine at that IP address or something like that. You can occasionally get issues here. The one thing you need to know is you'll click yes here, and just know that this is for uniquely identifying that machine. So just something to be aware of. So click yes, and then you're going to get prompted for a password. The password in this case is going to be Shiba1. It's the same as the username, so fairly straightforward. And we can see that we are greeted with a terminal that has a little bit of information, but we have our prompt down here, specifying we're on the host name of newt right here. Sometimes Putty may just not work. Sometimes Putty can just be fussy. I do recommend just doing this on Linux. It's just going to be a little bit easier. And you should probably have a Kali machine for yourself or something else that's similar enough that's connected to the TryHackMe VPN. An alternative to Putty, you may have an SSH binary on the computer. I'm going to skip past this just a little bit because we're going to see the Linux method here in just a moment. We will switch over. I'm going to go to my Linux terminal. I would suggest that you do the same. And I'm actually going to switch back, and we're going to grab this IP address here. You can click on that to copy it to your clipboard. And we're going to do SSH Shiba1 and then paste that in. Press enter, and then we type yes. And our password is Shiba1, again, all lowercase. And there we go. Cool. To clear the screen, I just press Control and L at the same time there. It's just a nice little shortcut. But we can type hostname and confirm that we're on newt. Cool. Nice and easy. Let's switch back over to the other, the web page itself. All right, let's move into task 5, section 2, which is running commands. So just how do we execute commands on the other machine? Awesome. Now that you've logged into the server, you're going to want to start, want to do things. And everything that can be done over SSH is done by running commands. To start out, we'll take a look at some of the basic commands, and your first command will be echo. So echo just takes whatever you type and it returns it in the terminal here. It's useful for debugging and other things like that. It's a very simple command. Just know that you type echo and then whatever you say is going to get echoed back at you. So just think of like saying something in a cave. It's going to get, it's going to come back to you. Much like the word it's named after, echo returns whatever is inputted after it. So you can see again here in this example that we've echoed hello and it comes back. Switching over to the SSH terminal, we can do echo hello and we get hello back. Nice and simple. Perfect. Congrats, you've just run your first command. We'll go ahead and mark that completed, and then we're going to move into task 6, which is section 2 again, manual pages and flags. All right, continuing on. Most of the commands you'll learn about have a lot of options that are not immediately known at first glance. These options are known as flags and have the format, so your actual command, so for example, echo, and then you put a flag here that changes what it does, and then you have your input after all that. These flags can be learned about using the man command. This brings up manual pages. If you haven't used it already, or haven't done it already, I do recommend checking out the introductory research room rather. It'll talk about how to use this appropriately, and it goes a little bit more in depth than what we're going to do here. The man command has the format man and then the command. Therefore, to learn about flags for the echo command, we would type man and then echo. And let's go ahead, we'll do that right now actually. So we'll clear the screen, and again, that is Control and L, man, and then echo. Perfect. So we have the manual page for how to use echo, and you can do this for most things in Linux, so it's very nice and easy. You can see that we have the actual name of the command, what it does, and then just some various descriptions and other bits and bobs that are useful. So to exit this, we're going to go ahead and press lowercase q, and that'll close it, and we'll switch back over to the web page. So we can see we have our nicely formatted document, very nice and easy. There's actually a fun version of this command, and I talk about it a little bit in that introductory researching room, where I have another video for that. There is a TLDR, too lazy didn't read command for the manual pages. You can install it. I think it might be in the Kali repository. Once you get a little bit more used to installing your own tools, you can grab it. TLDR takes the man page and it shortens it to a nice little paragraph. As I was too lazy to read the man page, so let me just grab this, and it's very fun. I had a system administrator that I worked with at the time show me that, and I got a good laugh out of it. It's very entertaining. So we get a lot of information, but the flags are stored in the description section. So we can see we have a bunch of flags here. So like -n, do not output to the trailing new line. You can just see that we have a bunch of options here. It's not really important to know. For example, the flag to remove the new line is -n. So to output Shiba without the new line, you would type echo and then -n and then Shiba. And let's do that real quick. Echo -n, and we'll do Shiba. And you can see that it gets shoved onto the same line as our terminal. So we don't have a trailing new line at the end. It's what would cause, so if we did Shiba or echo Shiba, it's what causes this enter right here. Some commands support the -h flag, which means you can type the command and then -h, and it gets you the help menu. How would you output hello without a new line? That's going to be echo -n and then hello. Maybe. There we go. Cool. Let's go ahead and jump into task 7, which is going to be the start of section 3, basic file operations. ls, so this is lowercase l by the way, is a command that lists information about every file / directory in the directory. It's just list files, list whatever's where you're at. Just running the ls command outputs the name of every file in the directory. So let's switch back over. We'll take a look at that real quick. And it looks like we have one file. This is red in my terminal. This is a custom color. It means that it's, I believe, an executable. And I just ran it with a couple more options here. You will probably typically run all of these options whenever you're running it. It puts everything out in a nice list, and it gives me some more information. So I can see that, yep, sure enough, this is an executable. It's because we have this X bit here, that if you see X there, that's executable. As with other commands, ls has many flags that can manipulate the output. For example, ls tac a shows all files / directories, including the ones that start with a dot. Now, in Windows, these are hidden files. The same thing works with Linux. So here we can see that I ran it with the tac a commands for all files. So it's list, I can't remember for the life of me what S does. This is just typically my LSA command that I use. And then all files. So here we can see we got a bunch of hidden stuff, and I do that we can see we only have just our Shiba1 executable. So we can see that, yeah, we can see hidden files with that. Useful for CTFs as well, because sometimes there are various files that we will want for the CTF that might just be hidden, and that's how they've decided to try to bamboozle us by hiding the files just by putting a dot. If you do over-the-wire war games, you will have a challenge that is specifically dealing with the dot files, and that's something I do recommend checking out, especially if you're getting started. That's actually a really nice follow-up to this room as well. If you don't jump at other TryHackMe content, I would check out Bandit by Over the Wire. What flag outputs all entries? -A. What flag outputs things in a long list format? That is going to be -L. I believe you will be able to get that by doing, and I'm going to clear the screen again, ls-tac-h. Never mind. We can just do man ls. Yeah, and you'll be able to see that we have the all here, and you can just scroll through this. I'm just using my scroll wheel. You can also do other things like use your arrow keys to scroll through. Yeah, and long list format for Q. Perfect. Let's go ahead and jump into task 8, which is going to be continuing on with section 3 rather. Cat, short for concatenate, does exactly that. It outputs the contents of files to the console. For example, given a file called a.txt, which contains the data hello, cat, and then that file here would output hello. So we can see the command right there. Cat a.txt gets you hello on the screen. Cat supports the -- help flag, meaning that you can see useful flags without going to the man page. We can do that right now. -- help, and we have a shortened version of the man page there. And we can see that we've got a nice image of that. What flag numbers all output lines? That's actually a really useful one to know. Goodness. I'm going to guess it's B here. Number non-empty output lines. I would say it's probably -B. Let's give that a try. Maybe. Oh, it's going to be -N rather. There we go. And I'm just hitting enter to submit my answers here, in case you were wondering. Let's go ahead and jump into task 9, which is going to be continuing section 3 rather. Touch is a pretty simple command. It creates files. Given the command touch b.txt, b.txt will be created. We'll go ahead and mark that as completed, and I'm going to demo that really quick. Touch b.txt. ls, and we can see we have that file. If we do cat b.txt, we can see that nothing is in there because we created an empty file. Cool. Let's go ahead and do task 10, which is going to be the last task in section 3, running a binary. All right, running a binary. So occasionally there will be times when you want to run downloaded or user-created programs. This is done by providing the full path to the binary. For example, say you download a binary that outputs newt. Providing the full path to that binary will execute it. So this is just an example of how we just provide the full path, and as long as it's executable, as we saw with Shiba being highlighted here with that executable, we can just run it. Nice and simple. Note, a binary is just executable code. Think of it as like, it's just a Windows executable. It's very similar to that. This seems like a good time to mention relative file paths. Every time you intend on running the binary, you don't need to provide a full path. You can use a relative path. Relative paths, so the chart below will assume the current path is temp and then AA. So relative path, putting a dot there means that you're starting in your current directory. So for example, if we want to run Shiba, we'll do this. And I just use tab to complete that because there was only one other file named starting with an S in this current directory. That says I want to run something out of my current directory, and it's Shiba1. Let's see. So we have another one, which is ... We can use that to run something out of the directory above us. So for example, if I wanted to use the cd command, which we'll cover in just a little bit, that is change directory, and then ... I'm in the home directory. And we can see that I'm here. And I can go back into Shiba1's home directory, but you can see that we can move around with that as well. And that means the directory above us. And there's one more. Here, I'm going to go back up. We can do cd and then tilde. There we go. I'm using a 60% keyboard to shoot this, so my keys a little bit, they're custom bound, and it takes me a moment to think of them while I'm doing this. But we can use cd and then tilde, and that means our home directory. So that is the shortcut for our home directory. So if we press that, we change to our home directory. If we want to run something out of our home directory, we can do that and then Shiba1, and there we go. Nice and simple. And there's a nice little chart that breaks it down there. These shortcuts are incredibly efficient and save time. These shortcuts for every command. So they work for every command, rather. So if I were to run ls and then dot, that means list everything in the current directory. It's the same as running just ls as well, as that'll run in your current directory. It assumes this dot by default. How would you run a binary called hello using the shortcut or directory shortcut dot? So we do dot and then hello. Maybe. How would you run a directory, or run a binary rather, called hello in your home directory using the shortcut tilde? It's going to be tilde and then hello. How would you run a binary called hello in the previous, or the directory above us using the shortcut dot dot? So it'd be dot dot and then hello. Perfect. Let's go ahead and move on to task 11, which is going to be our first binary, Shiba1. And again, make sure that you are SSH'd into the our machine here on TryHackMe. You do need to be connected to the VPN for this, otherwise it won't work. Shiba1 is going to be in your home directory once you've SSH'd in and you're connected to the TryHackMe VPN. Now that you've learned basic file operations, you can solve the first challenge. This is pretty simple. Create a file called newt.txt. Once you've run the binary, you'll be given a password for the user Shiba2. So we can go back here and we'll touch newt.txt, not exe, txt. Then we can run Shiba1, and there we go. It's going to be Pingu for the win. So I can copy that. So I'm just highlighting it, right clicking, and then we'll copy or we'll paste that in. We'll give it a moment. Maybe. There we go. Question has already been answered. Yeah, it was taking a second there. Awesome. So let's go ahead and move on to task 12, which is going to be SU, which is changing our users. Now that we have our next user password, it seems like a good time to cover SU. SU is a command that allows you to change the user without logging out and logging back in again. So this is really convenient, especially if you are a system administrator and you need to run something in a privileged context. So you need to run something as like the root user or some user that needs to be able to actually make changes to the file system. This allows you to change that user without logging out and doing that dance, because it's really inconvenient otherwise. For example, if you wanted to switch to Shiba2 while you're the user Shiba1, you would type SU and then Shiba2, and we already have our password for that. You would then be prompted for a password, and if you entered Shiba2's password correctly, you would then become Shiba2. Typing SU on its own is equivalent to typing SU and then root. So just something to be aware of. How do you specify what shell is used when you log in? Let's try SU -- help. There we go. So typing the -- help command, we can see that the -s allows us to specify our shell. That's really useful, especially if you don't like the shell that's given to you. In this case, I'm using bash. There are some other different command line shells. It's just how this looks and how it feels and how it handles like tab completion and other things like that. For our purposes, you don't really have to worry about that as much, but it's just nice to know. Switching back to the room, we can do -s, and let's see. Looks like we're going to move into section 4. I'm going to go ahead and switch over to the user Shiba2 now. So we'll do SU Shiba2, and then Pingu for the win. And there we go. We can see that we are Shiba2. I'm going to cd and then tilde, maybe. And we're in our home directory. So we can see we're in Shiba2's home directory, which has another binary. So make sure that you change your home directory with that. All right, task 13, section 4, Linux operators. This section will cover the operators most commonly used to interact with programs. The operators that will be covered in this section are greater than, ampersand, double ampersand, and then $sign. Over the following tasks, you will come to learn what each of these operators do. Perfect. Let's jump into task 14, which is going to be that first one, the greater than. All right, so the greater than operator is the operator for output redirection. So we use this to redirect our output, meaning that you can redirect the output of any command to a file. For example, if I were to run the command echo and then hello into a file, then instead of outputting hello to the console, then it would save that output to a file called file. And we can actually try that right now because that's a little confusing. So we'll do echo, and we'll do please subscribe to a file. And this file doesn't have to exist. It's going to create it for us. We'll do test.txt. And then we can cat test.txt. And there we go. Nice and simple. It is worth noting that if you were to use this operator on a file that already exists, so this would completely erase the contents of that file and replace it with the output from your command. So if I were to do echo DarkSec is awesome to test.txt, we can cat test.txt again, and we can see that it overwrote that. It erased it, and then it wrote to it. How would you output 20 to a file called test? So we'll echo 20, and then we'll do greater than test, and that should do it. Perfect. Let's go ahead and jump into task 15, which is going to be that double greater than. So that double greater than does mainly the same thing as the single greater than with one key difference. So this appends the output of a file to, or of a command to a file instead of erasing it. So if we do, let's do echo learn Linux, and then do double ampersand, or double greater than rather, test.txt. We can cat test.txt, and we can see that it's just added it as a new line on there instead of erasing the file. Awesome. Let's jump into task 16, which is going to be that double ampersand. Double ampersand means, as you might expect, it's the and. If you do programming, this is probably something that's pretty familiar with to you already. Meaning double ampersand allows you to execute a second command after the first one has executed successfully, meaning that ls and echo hello will work just fine, but adding a garbage command here and then echoing hello will fail. We can try that right here. So echo test and ls. We can see that it echoes test to the screen, and then it lists the directory contents. Nice and simple. Note, since the second command happens after the first command, you can use something called, or created in the first command in the second command. So if you make a file, you can address it and use it in the second command. Nice and very useful. All right, let's jump into task 17, which is going to be that single and. Much unlike double ampersand, and has nothing to do, so it doesn't have anything to do with that previous one at all. Try saying that 10 times fast. So a single ampersand is a background operator. So this means rather than running it at the same time, we're pushing it to the background and it runs outside of our view. Meaning that, say you run a command that takes 10 seconds to run, normally you wouldn't be able to run anything, so it takes up your terminal. So if I run sleep and then 5, we can see that my terminal just sits there. So we'll give it just a moment. It's waiting 5 seconds and my terminal comes back. But if I do that with sleep 5 and then ampersand, we can see that it's created a background task, and I can do other stuff like that. And it just does its own thing in the background. Nice and easy. Cool. Nice, especially if you have something that's going to take a really long time. You could just spawn it as a split off process, and it works quite nicely just shoving it in the background. One thing to note, you can play with error output and how the commands run in the background spit out its output. You may see stuff that comes to your terminal from a backgrounded task. Don't worry about it too much for right now. It's something that you'll play with a little bit more as you get used to Linux. All right, let's move to task 18, which is going to be that $sign. The $sign is an unusually special operator. It is used to denote environment variables. So if you're familiar with programming again, this is how you create variables. These are variables set by the computer. You can set them yourself, but we'll get into that. that are used to affect different processes and how they work. Meaning that if you edit these variables, you can change how certain processes work on your computer. For example, your current user is always stored in your environment variable called $, and then all caps user. You can view these variables with the echo command. So let's do that. Clear the screen. Again, that's Control and L, and we'll do echo and then $user. And there we go. We can see that, again, that other command we ran in the background finished as well. So we have our output of that, and I'll clear the screen and do that one more time. So we've got a clean output, and we can see that it's output that environment variable. All right, switch back over. So naturally, this means environment variables can be used as input for other commands as well. For example, say I wanted to create a file which is the name of our current user. I could do that with touch and then $user. And we can see that's demoed right here. We use the touch command and then the actual environment variable, and we can see it creates a file called Shiba2. I'm not going to do this because we already have a binary that's named Shiba2 and it'll actually screw that up. Recall that the double greater than operator rather appends output to the file, so you can see that there's a couple more examples in here, but they're not too important. It's just nice to know that you can use this the environment variables in other commands. It's very, very useful for scripting. Environment variables can also be set pretty easily, just running the export and then var name equals value. So we do export and then say, for example, we wanted to set a variable named newt to test. So we'll do export newt equals test. And I'm actually going to do this with a space because that bothers me. Never mind. There we go. Newt equals test. I guess you can't use a space there, but then we'll go ahead and echo and then $newt. Hold on. Lowercase. There we go. So we can see lowercase case does matter on those, but we can see that we successfully stored test into that environment variable that we created. How would you set newt equal to 1111? Would do export newt equals that amount. What is the value of the home environment variable? We can do echo and then $home, and we can see our home directory there. And then we have this. Copy that, and it should be correct. Perfect. Let's jump into task 19, which is going to be the pipe operator. Continuing with the trend of very special operators, we have the pipe. This is probably my favorite. It's probably the most useful one. The pipe is unique because while operators like double greater than allow you to store the output of a command, the pipe operator allows you to take the output of a command and use it as the input for the second command. For example, I will use the cat command to get the output of a file and pipe that into grep to search for a specific string. We'll talk about grep a little bit later, but this is just a nice example. So here we can see we have cat and then test. We have a bunch of things in test here. And then if we do cat test and then we pass it, so this gets the output here and then it passes it to this command grep, which is find. Essentially, it's like searching Control F and then a term here. So we have the term newt and we can see that sure enough it's there. So it finds it in that file. And then we can see we're doing that again with the grep and 123. It is worth noting that not all commands support the pipe, and some that do require you to use the dash instead of input. So cat and then dash. So always check to see if the command does support it. Most of the time it will. It's just something to be aware of. All right, let's jump into task 20, which is going to be the semicolon. The semicolon operator works a lot like the double ampersand. However, it does not require the first command to execute successfully. This means that you can do the whatever garbage command this is, and then ls. So it's just a run these commands in this order. All right, so yeah, let's go ahead and demo that real quick. So we'll do ls, actually we'll do a garbage command here, and then semicolon, and then we'll do ls. And we can see that even though this first one failed, we can see that it did go through and run that list contents or list files in the current directory. All right, let's jump into task 21, which is going to be our second binary, Shiba 2. This challenge is pretty simple. The binary is checking to see if the environment variable test1234 exists, and if it's set equal to the current $user environment variable. So we can go through and do export, and then let's see, test1234 equals, and then we can do $user, and then we can go ahead and echo $test1234, and we can see that it's set to our user variable. And now we can go ahead and run Shiba 2. It's going to check that, and sure enough, we have our password for Shiba 3. So we'll copy that. We're going to put that in here as our answer. And we're going to switch over to Shiba 3. And I'm going to do a dash here so it puts me in the Shiba 3 home directory. There we go. So we've switched over and we can see that we're also in the home directory for Shiba 3. And we have, it looks like a test directory. So let's move into task 22, which is going to be advanced file operators. Much like Windows, files have a lot of complexity to them. Multiple different parameters have to be modified to allow certain users to read files, write to files, and execute certain files. This section will cover modifying these parameters. Awesome. Let's move into task 23, a bit of background. So recall that ls has different flags that allow you to see or allow you to view information about different types of files. So here we can see we've got a bunch of info here at the start. That is actually our file properties. This is the owner. This is the actual read, write, and execute properties. We can see the file size, when it was last modified, and then the actual file name. This image has all three of the attributes covered in this section. More specifically, we're interested in these three. So again, the owner, user, the owner group, and then the actual read-write attributes and other things like that. These attributes all are in order of the file permissions, the owner of the file, and then the group of the files in. The next few tasks, we'll go over the command to modify these attributes. So we'll go ahead and mark that as completed and click into task 24, which is chmod, one of the most useful commands in Linux as well. All right, chmod allows you to set the different permissions for a file and control who can read it. The syntax of the command is typically chmod, and then the file permissions, and then the file. The interesting part is how the permissions are set. They're set using a 3-digit number where each digit controls a specific permission, meaning the file or the first digit controls the permissions for a user, the second digit controls the permission for a group, and the third digit controls permissions for everyone that's not part of the user or the group. So that's everyone else. Now the value of the digits control whether they can read, write, or execute it, or the file in question, or they can do all three. And to properly calculate it, this value, we need to do a little bit of math. So we have 1 through 7. Zeros included here. It means that user can't do anything to it. So 1 means the file can be executed, 2 means the file can be written to, and then 3 means that it can be executed and written to. So again, this is so we have this as a combination of 1 and 2. This fourth one is what I'm looking for, so the file can be read. This 1, 2, and 4 are actually the magic numbers that make up everything. So you can see 3, 5, 6, and 7 are all combinations of 1, 2, and 4. So depending on what bits are turned on, so if there is, this is actually in binary, so it's a 3-bit value for each one. So if the first bit is turned on, that means it can be executed. The second bit can be turned on. That means it can be written to. And then the third bit is the read and write. And everything else, you can see it's a combination of that. This is something that I do recommend reading a little bit further into in case this is confusing. The way these values are calculated is this. So yeah, the digit 1 means the file can be executed. The digit 2 means it can be written to. And the digit 4 means it can be read. You can get the different permissions by adding these digits together. So we can end up having 777, which means all users have all permissions. So This is user. The user that actually owns it can read, write, and execute it. The group that they're in can read, write, and execute it, and everyone else can do the same thing too. In this case, the user who owns it can, let's see, they can write to it, and then they can also go through and execute it. The group that they're in can read it, and everyone else can execute it. And then we can see here at the end, the file can be read by the user that owns the file. The file can be read and executed by the group that owns the file, and then everyone else can read and execute it as well. And we can see that's just a combination of that 4 and a 1 for here. ls provides a helpful way of viewing the permissions on files of the current directory. Yeah, and there we can see with ls, we could see all of the permissions before. This is something I talked about a little bit earlier in the room too. Recall that file permissions are divided up into those 3 sections, and here you can see that we just have it a little bit more broken out here. So we have the user, the group, and then the actual everyone else. And you can see it a little bit easier up here. Don't worry about this first one here. We don't really have to worry about it right now, but you can see that there's different permissions. So for example, the bash history file here, we can read it and write to it as our current user, but no one else can do anything else to it. So read write means you might expect to read and write, or RNW rather, meaning the user has read write permissions to the file. Following that logic, that means members of the group and everyone else, and we have read permissions. And again, make sure it's explicitly stated here. Otherwise, if it's this bar, it means they don't have it. To convert the numbers, or to convert that to the numbers, to convert that to numbers, the permissions for that file in order form 644. So we can see that read and write gets you 6, and then everyone else has read, which gets you 4. We can test this by trying to change the permissions, but we can see that there's just this nice permissions blob down here. When we try to change the permissions, the 644 to 644, nothing happens because the permissions are already that. So we can see that they're already set to that, which we'll glaze over that a little bit because it's not too important. But long and short, typing ls, tac la, or al, it doesn't really matter what order these are in, is going to show you the permissions, and you can go through and view what permissions you have and what permissions other people have. So what permissions mean the user... What permissions can the user have to read the file, the group read and write to the file, and no one else can read, write, or execute to the file? That is going to be 4, 6 rather, and then 0, I think. Let's give that a try. There we go. What permissions mean the user can read and write and execute to the file? So that's a 7. The group can read, write, and execute to the file. Oh, everyone can do everything to it. So it's going to be 777. Don't ever set your files to this. It means that everyone on the computer can write to it. That's really bad, especially if it's got other permissions set to it. Typically, you shouldn't use 777 unless you absolutely have to. Let's move into section 25, which is chown. As you might have guessed, this is a modify. So change modifications or change modifiers. This is change ownership. So it changes what user and what group owns the file. Recall that ls shows us our username twice. That is because we have a user and then a group that is created automatically with a new user. These attributes are the user and the group attributes respectively. Recall that we can edit the permissions for these attributes, so it stands to reason that we can also change these attributes. This is done using the chown command, which allows us to change the user and group for any file. The syntax for this command is chown user and then :group file. So it's the chown command user :group and then the file name itself. For example, if we wanted to change the owner of file to Shiba2 as well as the group to Shiba2, we could use this command. So it's chown and then Shiba2 for both of these separated by : and then the file. So one quick note, you can only change the ownership of the file if you are above that user. That means you have more power than them. So if you're the root user, the administrator for the computer, you can change it regardless, or you own the file, then you can actually change it. But you have to have sufficient permissions to modify it. I can't go through and change your files. For example, if we were both users on the system, I can't go through and change all your files willy-nilly unless I had super user powers. And that's, as you can see, it's a security mechanism. You can also use chown without specifying a group so that you can just change the user of the file. So we can see here chown and then Shiba1. Note that there's no colon here. It just changes the actual user who owns it. You can put a colon before it, and you can change the group as well. It goes vice versa for this. How would you change the owner of a file to paradox? So we'll do chown and then paradox and then I believe file. Let's cut that. Yep, that should be it. What about the owner and the group of the file to paradox? So we can do that again, and we'll go here and just add paradox. What flag allows you to operate on every file in a directory at once? I believe that should be -r. There we go. And we get that from doing, let's do chown-h, chown-help. And we can see right here the -R or -- recursive means operate on files and directories recursively, which means everything in your directory and below it. Very useful, especially if you want to change your directory and you might have screwed up permissions and you need to share it with another user. Awesome. Let's move on to task 26, which is going to be the rm command, otherwise known as remove. Let's take a break from all the permissions and math and look at something that can completely destroy your whole Linux system if used carelessly. rm, as you might have guessed, means remove, and that's exactly what it does. So here we can see that we're running ls, and we can see we have a file in our directory running rm and then just file, so just the file name. We'll go through and just remove it as long as we're permissions to do so. And we can see our listing the file contents, or listing the directory contents again, rather, reveals that there isn't anything there. As you can imagine, this is incredibly dangerous, as you can remove some very important files and render your system completely unusable. It is not worth noting that you can write permissions, or that you need write permissions to a file to delete it, so you can't just delete any file if you're a regular user. It's worth noting, rather, you have to have permissions to a file to delete it. That's what this means. So rm and then etc shadow, which is a file that's owned by root. We can't actually delete that as a regular user, and we'll confirm that here. Rm etc shadow, and we can see, we'll try to write it, and we can see that permission is denied. What flag deletes every file and a directory? Let's do rm --help. And remove directories and their contents recursively. It should be -r. How do you suppress all warning prompts? Let's go through. And I'm going to scroll up. So it's going to be the -f, the force flag. Perfect. Let's go ahead and move on to task 27, which is going to be the mv operator. mv allows you to move files, and directories for that matter, from one place to another. The syntax for the command is mv, and then file, and then the destination. So if I wanted to move a file to my home directory, I could type mv, and then the file name itself. Keep in mind, this is assuming that we're in the same directory as this file, and then tilde to move it to our home directory. Taking a look down here, we can see that we've got a quick demo of exactly that. We're just moving it out of the temporary directory here into our home directory. And you can also use move to change the name of a file. So we don't have a rename command so much as we can just use move to move it to the same spot, but a different file name. So move and then file, and then to our home directory, and then file name, just this random gibberish. We'll actually rename that file to that ghfds. And we can see a demo of that just down below. So mv file, and then tilde, and then just our home directory. We can see that we've moved it to our home directory here. And then we want to move it to our home directory, but named this. If we do ls, it's not in our temp directory anymore, but we can see that it's been moved to our home directory, and it's named this now. How would you move a file, or move file to temp? It's going to be mv file/tmp. Perfect. Let's move on to task 28, which is going to be the cp command. cp does mainly the same thing as move, except instead of moving to the file, it duplicates it, so it's just the copy command. The syntax is also the same as MV, meaning the syntax is cp, file, and then destination. So same as MV, and we can see that if we do cp, here, I'm going to make a file called test.txt, and we'll cp test.txt to temp and ls temp. We can see that we now have this test.txt there. Cool. Let's move on to task 29, which is cd and or ampersand mkdir. In Windows, there are folders. Folders allow you to store multiple files in a single group, which makes them easier to organize and access. Linux has the same thing, except they're called directories. That name is pretty much interchangeable with Windows. I wouldn't worry too much about that. Linux allows you to change the location of the current directory through the use of the cd command. The syntax of the cd command is this, so cd, so change directory, and then the directory. And I demoed this a little bit earlier as well. So say, for example, we wanted to clear the screen again, and that is Control-L, cd, and then tmp. We can see that we're in the temp directory. So present working directory means we're in temp. Cd and then tilde puts us back in our home directory. This brings us to mkdir. Occasionally, you'll want to make a new directory to store files in, and this is done using mkdir. The syntax of mkdir is mkdir and then the directory name. We'll mkdir, and then we'll do please subscribe. And we can see that we have a new directory here that's called please subscribe. Perfect. As you might have noticed, ls shows directories as well, and I've got them highlighted in a different color here. This is just a custom scheme that I have for my tmux session. Using relative paths, how would you cd to your home directory? That is going to be cd and then tilde. Using absolute paths, how would you make a directory called test in temp? Well, luckily enough for us, we kind of did that. So we'll do mkdir /temp and then test. Awesome. Let's move on to task 30, which is going to be ln. All right. ln is a weird one because it has two different main uses. One of those is what's known as hard linking, which completely duplicates the file and links the duplicate to the original copy, meaning whatever is done to the created link is also done to the original file. It's where you can have a file that exists in two locations effectively. The ln syntax is ln source and then destination. So we can see that we're echoing hello to file, and we're seeing that file exists. If we cat it, we can see that it has hello in it, and then we link file to file2. So we have another file that we're creating in the same directory that's named file2. And then ls, we can see that we have two files. They're identical here. They have the same properties, but they are symlinked to each other, or hard linked rather. So if we add newt to a line on the bottom of file 2, and we cat file the original one, we can see that newt has been added to it because it's effectively the same file, it's just a copy of it. It's important to be careful with hard links, as depending on what you're doing, it can be very easy to erase data from a file. The next form of linking is symbolic linking, so symlinking. While a hard linked file contains the data in the original file, a symlink is just a glorified reference. So if you're familiar with C programming, this is similar to a pointer, meaning that the actual symbolic link has no data in it at all. It's just a reference to another file. So it's just it's like a signpost that points to the other file, and we can see it right down here that it says, hey, I'm just referencing that other file. If you're going to write to me or do anything to me, you need this. So nice and easy. It's a little bit more useful situationally. I wouldn't worry too much about this. It's just good to know about. The syntax for a symbolic link is the exact same, but it uses the -s flag. So to create a symlink, you would run the command ln-s and then the file and then your destination. So very similar to the hard link. So ls shows that it's a symbolic link with that arrow there, pointing to the link that it's actually referencing. So it's in the same directory. It just says, hey, this is a symlink to this file. So it has full 777 permissions, meaning that in theory you can execute the symlink However, since it's just a reference, in reality it has the same permissions as the original file. Very important thing to know. How would I link home test file to temp test? That is going to be ln home test file temp test. Nice and easy. And do note this is a hard link, not a symlink. Alright, let's jump into task 31, which is going to be the find command. There is a dedicated room over this command, and I do recommend checking it out. I will try to put a link to this in the video description below. However, it's pretty easy to find on TryHackMe. Find is an incredibly powerful but incredibly simple command. It allows you to do just as it says, find files. It does this by listing every file in the current directory. So if you ran find and then /temp, it would list every file in /temp. And we can see it's doing just that here. It's worth noting that find is recursive, so it searches every directory that is in the original directory you provided, so anything below it also gets searched. Meaning that if you were to run find /, so the actual root of the file system here, it would list every file on the operating system. Another thing worth noting is that it can only list files and directories you have permissions to access, meaning that you can't just list every file as every user, so you can't list things you don't own. The true power of this command comes from the parameters you can provide it. So you can use find and then dir and then -user. This is very flexible. It allows you to do a lot with it. To list every file owned by a specific user. You can use find dir /group to list every file owned by a specific group. The sheer customizability of the command is its most powerful feature. And again, this has its own room for it, so it's very, very nice to go through that room. Here we can see we're running an example where we're checking with find in the temp directory everything owned by the user root. And we can see that there's quite a few files there. This is one command I recommend reading the manual page on to learn all of its options. This command is invaluable when working with files, and I do recommend, instead of reading the manual page for it, I do recommend just going through and doing that room. It's a little bit easier. How do you find files that have specific permissions? Let's go over to our terminal here, and we'll do find, and then --help. And then we'll scroll up. And we should be able to find... Let's see, no more operations. We should have a perms command here. There we go, -perm. That should do it. And you can see that from the main page as well. How would you find all files in the /home directory? And we don't even have to go over to the terminal for that. It's just going to be find /home. How would you find all files owned by Paradox on the whole system? So that's going to be find /user Paradox. Awesome. Let's move on to task 32, which is going to be grep. I can say without reservation that grep is one of the most useful commands to learn. We used it a little bit earlier. It's essentially your filter command. Very, very useful. It allows you to find data inside of data. So you can essentially dump what's in a file out and start shifting through it. When working with large files or a large output, it is arguably the best way to narrow the output down to find what you're looking for. The syntax of the command is grep, and then you have a string, and then the file that you're going to search through. However, file is optional when you're using piping, so you can pipe things to this and grep things out of it. You can search multiple files at the same time, meaning you can theoretically do so grep and then the string you're looking for, and then your files here. So you can do as many as you want. For instance, let's say you have the file name of test1234, but you don't know where it is on the system. Find can be used to list every file on the operating system, and grep can be used to find the actual file. So we can do find, and then we can just do find star, or just find and then /, and then we pass that to grep using pipe, and then test1234. And here we can see that it found it right away in var log test. Grep comes in and saves the day. What about if you have a bunch of data and you want to see a string hello, or see if the string hello is in it, and if so, what line number it's at? We can do that with grep, and then our string here, hello, and then the file name of test we're going to be looking through, and then -n for the flag to find what line that's on. And we can see that it outputs right there. I'm sure you can see how useful this command is. When searching logs for the cause of an error message, when parsing large amounts of data for that specific piece, when searching every file in a directory for that one line you may need to change. So a bunch of different use cases. Another important thing to note is that grep supports regular expressions. That, you see, I wasn't being entirely truthful with you, so props if you got that reference. When I said the syntax is grep, strings, and then file. So regex is something you don't necessarily need to know about right now. If you've had to use regex, you know that it's kind of a pain to learn initially. There are different sites that make this useful. Essentially, think of it this way. You can state very exactly the pattern that you're looking for. So if you have a pattern of words that you want, or a pattern like you need the start of a line in a very specific way, you can use regex and regular expressions. So it's outside of the scope of this room, just nice to know that grep can do it. What flag lists line numbers for every string found? We actually saw this earlier with the -n. How would I search for the string boop in the file AAAA in the directory temp? We will go through and do find, let's see, grep boop, and I'm going to cut this, and then temp, and then AAAA. There we go. Let's move on to task 33, which is going to be our third binary named Shiba3. We've been through a lot in this section, and the challenge for this binary will reflect that. The first step is actually finding the binary. I'm not heartless though, so I will give you the name of the binary. The name of the binary is called Shiba4. The actual binary will check for two things. So let's go through and we'll find it first before we do anything else. I'm going to clear the screen with Control and L. We'll do find slash and then Shiba4. We'll do grep Shiba4 rather. And we can see that it's in etc Shiba4. And I'm going to Control C to cancel that. We'll do cd etc Shiba. Let's see. Can we read it? Interesting. I think we might have cheesed past this. Let's try and see if that's the password. Interesting. The actual binary will check for two things. It will be checking that there's a directory called test in your home directory, so we've already got that. That was actually already made for us. And it will be checking that inside that directory there's a file called test1234. Interesting. I'm not quite sure that we did that the right way, but that'll work. If you go back through and we'll scroll up here, we should be able to find the actual location of that, maybe. I'm up arrowing right now to find the command. I'm just getting rid of our errors right there. Okay, so we have Shiba4, maybe. Let's see what we got. Opt secret Shiba4. There we go. I think that's what we were supposed to find. cd opt secret, and we can see that we have Shiba4, and that is the actual binary there. Whoopsie. Well, we found the other password on the system. That's not a safe security practice, but I mean, it worked. We can go through and let's make a file. So we'll do touch and then home Shiba3 test. So we needed to make that test directory, which already is made for us, so we don't really have to worry about that. And then I believe it was test 1234. And then if we go through and run Shiba4, we can see that it outputs that password. And sure enough, we've got that password there, which is what we found and kind of guessed anyways, but that's how you're supposed to do it. Let's move on to task 34, which is going to be our miscellaneous section. It's all the nice, useful things that we do need to know moving forward. Even though we've gone over how the Linux operating system works and some of its most useful features and commands, there are some useful commands and concepts that haven't been covered in previous sections. This section is dedicated to all those miscellaneous commands and concepts that are useful to know. Awesome. Let's move on to task 35, which is going to be sudo. Real quick before we do that, we're actually going to do su and then dash shiba 4 and then test 1, 2, 3, 4. And we're going to change over to the shiba 4 user and confirm that we're in our home directory. Throughout this room, you might have seen me mention the root user. The root user is the equivalent of the administrator user on Windows, and like Windows, certain commands and certain things you've downloaded from the internet to actually run certain things, you need to have administrator permissions. So if you want to make changes to the file system to something you don't own, you need to be root. That's where sudo comes in. Sudo, or sudo as it's typically referred to, is Linux's run as administrator button. So when you get that prompt to run as administrator in Windows, this is effectively the same thing. And the syntax goes sudo and then the command. So here we can see we're doing the whoami command, and we can see that we're running this as the newt user. If we do that as sudo, it runs it as root, and we'll do that right now. I'm going to check and see what I can run with sudo using sudo-l. It looks like we don't have sudo permission, so we won't worry about that. Whoami is just a command that states your current user, so yeah, we can see the output of it. The big thing to know here is that running with sudo, we can run things as root. As you can see, when using sudo, the command is run as root. It is important to note that you need to have your current user's password to use it. Again, like Windows, not every user has permission to use sudo, but most Linux operating systems set up a user that has permissions when you install it. Assuming you create a new user, you want to give sudo permissions to, the man page for sudo has a section on how to add user permissions. So in English, this says, if you have a user and you want to give it sudo permissions, there's a section in the man page for it, for the command sudo, that shows you how to do that. It's very straightforward. You can also Google it, and it'll give you an example of how you need to change that. Very straightforward. It is also worth noting that you can configure sudo to run commands as other users. Again, the man page has a section on that, so sudo has a very nice man page. How do you specify which user you want to run a command as? I believe that is going to be -u. There we go. How would I run whoami as the user gen? That's going to be sudo-u gen and then whoami. How do you list your current sudo privileges? What commands you can run and who you can run them as. And you saw me do that earlier with the command flag-l. Awesome. Let's go to task 36, which is going to be adding users and groups. You know how to modify permissions for users and groups. Therefore, it's helpful to know how to create them. Luckily, Linux provides a nice, helpful way to do this with the add user and add group commands. The syntax for both of these commands are add user and then the username, and then add group and then the group name. And here you can see we're doing exactly that. One thing to note, and it says right here, you do need to be root to actually add these users, and that makes sense. You have to have super user permissions in order to do that. And we've got an example here that we're running that with sudo, add user, and then newt. And you can see that it's asking for some base information. We do need to provide a password. We don't have to provide anything else here. And then we can do the same thing with adding a group. Again, you need to be root to do that, but you can add groups pretty easily. It doesn't ask for any information there, but nice way that you can add groups and segment out permissions. It's important to note that only root has permissions to add users and groups, as seen with the failure when I attempted to run the commands without sudo. You may be wondering how to add a user to a group. That is done with the usermod command. The syntax for that is usermod-a-G, and then the groups, you can do this with multiple groups just separated by commas, and then the user. Meaning that if I wanted to add the user newt to group B, I would run usermod-lowercase a, capital G, B, so that group B, and then the username of newt. And we can see there's an example of that running below. So note ID is a command that allows you to view basic information about a user, and we can see that we've got the groups that we're in here. How would I add the user test to the group test? So we're going to use, I believe we want sudo, and then user mod, and then dash A, dash capital G. Let me move my cursor. Test, and then test. I think that should be correct. Perfect. Let's move on to task 37, which is going to be one of my favorites, the text editor Nano. Up until this point, you may have seen me only using the 2 greater than signs to add content to a file. Luckily, that's not the only way to do things. Nano is a terminal text-based editor that allows us to do exactly that. The syntax for Nano is nano, and then just the file name you want to write to. You do need to have permissions to do this, though. Sometimes you'll have to add sudo to that in order to actually type or write to another file. For example, typing just nano test will take you to this screen. We could do exactly that. So we'll clear the screen with Control and L, and then nano, and then test. We're writing to a file named test that doesn't exist yet, but once we save it, it will exist in our user's home directory. I'm going to do Control and X to exit it, and we'll switch back over here. But we can see that we've got the base nano screen. From here, type until your heart's content. And you can see we've added a bunch of content here, and we do Control S to save. These are all your commands here at the bottom. It's nice and easy. And then Control X to exit out. Nano has a lot of commands inside its text editor, and the text editor as a whole probably warrants a room on its own. But 99% of the time, you're going to want to use Control X. Note that means Control X. Most of the time, you always see the caret and then the key, and that caret means control. Once you press Control and X, you'll be prompted with a screen. So it says, do you want to actually save this, or do you want to press no? That's going to be Y or yes, and then you can do Control C to actually cancel out of that. So press yes, and it's going to ask, do you want to change the name of the file? And if you want it as a test, you can just press enter there, or you can type a new name for it. So type whatever you want the file to be named, press enter, and you'll be greeted with your terminal screen. You notice the file is there, and everything you typed is also there. So you can see that we've got the file here in our current directory. Just pay attention to this top bit for that. And then catting that file will show that we've got everything there. Now you can actually edit text files. And we'll go ahead and mark that as completed and move on to task 38, which is going to be basic shell scripting. Sorry about that. I had to pause for a moment. My cat named Bash, actually named after the Linux terminal, is below my desk while I'm doing recording. And if you hear a jingle, that is him being a kitten. Linux provides us a way to run commands one after another without using any special operators. This can be done by storing the commands you want in a file with the .sh extension. You don't actually need this file extension, however, as you're getting used to Linux, I do recommend using this. It just specifies that it's a .sh or a scripting file. So if we wanted to run the commands hello, and then we wanted to echo who am I, and then the output of who am I, we can do that with this file here. One note, we do need to make this executable in order to actually have it run though. If we save and run, so bash, so calling our shell itself, and then the actual file, this is assuming we're in the same directory as it executes those commands in order. So it says hello, so it's echoing hello, and then who am I, and then it's running the command who am I. It echoed out hello, then it echoed out who am I, then it ran who am I exactly as the file said it should. Congratulations on your first bash script. And this is something I do recommend go through and run this. You can go through and create this file with bash just to mess around with it and start getting used to shell scripting. It is worth noting that the .sh extension isn't technically needed, and I mentioned this before, but you need to provide what's called a shebang, and then the path to the shell we want to use to execute our command. So we can see that we've got the shebang here. So that is a £, and then exclamation point, and then the path to the shell we want to execute it with. In this case, we're using bin bash. And if we make that executable, we can just run this file without calling bash explicitly, because the file will just say, hey, I already have a shebang here, you can just run me. From there on, we can remove the .sh extension and make the file executable. A lot of times I will just leave the .sh extension for my own sanity and just leave it there. As it's nice to know that, hey, this is a scripting file that I created beforehand. Note the shebang must be at the start of the file, so we do have to have this before we have any other content. We'll go ahead and mark that as completed, and then we're going to move on to task 39, important files and directories. This is mostly a dictionary task. This is just something to know. I'm going to go through these probably in a pretty cursory manner. You will get used to these as you use Linux a little bit more. Throughout this room, you've seen a lot of files and directories, so I'm using this task to define what the most important of those files and directories do. Before that, it is worth noting exactly how the Linux file system works. Everything on the Linux file system extends from the /. This is the root of your file system. / is the equivalent of C in Windows, or C: in Windows. It's just the start of your hard drive in Windows. In Windows, this is technically your system drive. It gets a little bit different with that, but just know that / is the start of your file system. Meaning that, for example, if you were to delete /, you would delete everything in your file system. Don't do that. Please don't do that. That's a bad thing to do. If you delete all the files on Linux, it means Linux won't work anymore. So etc password. This stores your basic user information. This was historically used to save passwords. This is often referred to as etc password, or instead of etc passwd. And you can just see different files, and you can see that there's shells that they have here. So you can see that all these users are using bash. There's some other ones in here that I'll note quickly. No logon means that it doesn't have a shell that's associated with it. Just something to be aware of. Etc shadow, this has all the password hashes for all the users on the system. We're not showing that because if you have those, you can go through and attempt to crack those passwords. Essentially, this is what stores your password data. /tmp, that's a temp directory. Every time the system starts up, it wipes that directory, so you can just put temporary stuff in there. Don't save anything in there that you care about. The etc sudoers file, this is too long to show. That's great. This is where you can actually go through and add different users to use the sudo command. So we'd modify this if we wanted to add Shiba 4 to the actual sudoers file. The home directory it stores all of your users' home directories. It's essentially your desktop folder, and everything will be in there. And you can see it's a little hard to read here, but we have Shiba 1, 2, 3, and 4 in here. And we have Newt and Newt. Those are all your different users on the system, and they all have their desktop and download folders in their own subfolders. /root is the root user's home directory. This is the equivalent of the administrator directory, and again, this isn't shown because of a spoiler. We're going to be using a CTF, or doing a CTF here at the end, to actually elevate our permissions. And the flag is in there. Your /usr is where all the software is installed. You don't need to really worry about this. Bin and sbin are binaries and system binaries. They're critical system files. Don't worry about these. Don't delete them. Please, for the love of God, don't delete them. You will break your Linux installation. /var is the miscellaneous directories, or is a miscellaneous directory, a myriad of processes store data in /var. Typically, you won't have to worry about this. The only thing that's useful to know with var is that there are a lot of times logs stored in there, and I believe you have your web directory in there if you're running like an Apache server or something. $path stores all the binaries you'll be able to run. This is the same as your path on Windows. Essentially, if you're typing something like, if we wanted to type cd, this is calling the cd binary on our system that's going to be in this path variable. And it's just this very long string. You don't have to worry too much about this. You'll learn a little bit more about this when you start doing Linux privilege escalation, which is going to cover manipulating this path a little bit more. And you can see we've done just that with echoing the path. Awesome. Let's go ahead and move into task 40, which is going to be installing packages with apt. All right. This is a bit hard to make a task on depending on the Linux installation you install. So there's different package managers and different Linux versions. In this case, we're just going to talk briefly about apt, which is what you'll use on Kali. Kali is the main hacking operating system that you'll be using throughout your career. There are other operating systems that you can use. I would recommend just sticking to Kali for now because it's what most people end up using. So the syntax to install packages is apt install and then the package name. And in this case, we're seeing that you do have to have root powers for that. And we're installing the Python dev package here, and it sits and runs. One common joke that we see in industry is that if you ever want to look busy, you can just run apt-get update, or apt update rather, which just checks for updates for your system. Run that continuously if you want to have your computer look like it's doing something. It's great if you have someone that's behind you that's like recording and they need like B-roll footage or things like that. Not that I would ever do that, never at all. Python dev is just a random package. It's just a nice one for demonstrating here, but you can see this takes a little while. So apt downloads the package from a repository, which is just a list of programs. It then installs and gives your command prompt back. This just takes a while. So apt has a lot of subcommands, and again warrants a room on its own. Again, we're just touching on it here to know that it exists. So for example, we can do sudo apt install tmux. If you wanted to get tmux installed, again, you need to have sudo powers, which we don't actually have as Shiba 4. Switching back over to the room, we can mark this as completed, and we'll swap over to task 41, which is processes. And there's a lot in this task, but we'll go through it pretty quickly. Every binary you execute on Linux is a process while it's run. A process is just another word for a running program. A list of user-created processes can be used or can be viewed with the ps command, and we can do that right here. And we can see that we're running bash and then the ps command. And we can see an example of that there too. While this is technically all the user-created processes, it's likely not the information you're looking for if you're examining processes. To view a list of all system processes, you have to use the -ef flag, and this is just an example that output. I'm not going to run this because it's very long. There's a lot that runs in the background. Every process that is currently running on the system is listed, along with some basic information about the process. Arguably, the most interesting part about that list is the second column, the 3 to 5 digit numbers. This is the process ID. You'll use this, I recommend taking a look at the room ICE if you're interested in using this a little bit more. We'll cover this a little bit in that room with how to migrate between processes once you haven't taken over them as an attacker. So these are known as process IDs, and they're how you interact with processes. 90% of the time, you'll be wanting to stop these processes, and that's done with the kill command. An apt choice of naming, I know. Yeah, this is a great command name. The syntax of the kill command is kill, and then the process ID, and again, it's going to be the number in this column. The second one here is the parent process ID, which is what started that command, or what started that process. So example, if we want to kill the process with the process ID 7667, we can do that with kill and then that. You do need to have sufficient permissions to kill it though, so if you are trying to kill something that's owned by root, you can't do that. After running kill, the process no longer shows up, and you can see if you scroll through here that it no longer shows up. Another useful way to interact with process IDs is through the command top. Top shows you the processes that are taking up the most system resources, and I will show that one. I do have a personal favorite process that, or a favorite version of this command, which is called htop. It shows it in color. I don't know if we actually have it on the system. Oh, we do! Awesome! So this is htop. It's the same as top, but it's colorful, and it's great. But you can see how much memory usage and other stuff that we have here, uptime, other things like that, and we can exit out of that with Control and C. Use htop, it's better than top. Cool. So you can see just everything that's running, and it shows you various bits of information about it, like how much memory, how much CPU it's using, and so on and so forth. Let's move over to task 42, which is going to be our second to last task before we do our actual CTF and get the true ending. But we've been through a lot, but we're finally at the end. I hope every one of you enjoyed this room and learned something. This has been a marathon of a room. Let's move over to task 43, and we're going to get our CTF over, and we're going to get our badge for finishing this room, and it's going to be fantastic. If you're ever curious if a room has a badge, just click on the awards tab. And I can tell you after doing 43 tasks, you have definitely earned it. So I'm not going to leave you without one final little parting gift. This is a penetration site or penetration testing site, and I wouldn't feel right if I didn't hide a flag. There's one flag on this machine, and it's in root /root.txt. Everything that you need to get there is in this room, so I'm going to leave you with this. I do recommend attempting this on your own. This is often enough one that you'll come back to. I'm going to show you in just a moment how we can just go through and get this flag, though. All right, and we're back. So I've gone ahead and I've already switched over to Sheba 2. You do need to be this user to finish up this room and read the file that we need in order to get root powers. To switch over, you can do the command su and then dash and then Sheba 2, and then you'll need the password pingu ftw for the win. Just something to be aware of. And then we can go through and we are going to cat this file. And you would find this just by looking at various interesting files that each of the users on the system have. I'm just going through this pretty quickly because this can take a little while to find otherwise. And here we can see in this var log, and again, this is where various logs can be added. We have this file test1234. This file contains a username password pair for the user newt. So if we go su dash newt, we'll do the password not so fast. And then we can go ahead and do the sudo dash l command to see what we can run as root rather, and not so fast again for the password. And we can see once we switched over to the user newt that we can run all commands as all users. So this means we effectively have root powers. We can go ahead and switch over to root by doing su and then dash with no username specified, and then we'll do hold on, we need to cancel out of that, so we'll do some bad passwords here because we need sudo before that. Sudo su dash not okay, never mind, we've already typed in our password there. So typically you're going to be prompted for a password, but you can see by running the command who am I or looking at the start of the terminal, we can see that we've already switched over to root, and doing id we can see that we are root as well. Doing that, we can do cat root.txt, copy this out, and this should be our last thing that we need to complete this room. Sure enough, submitting that, we can see that we get the pop-up saying congratulations, you've completed this room. And I'm going to terminate my machine as well. Otherwise, that is about going to do it for today. If you have any questions, I will have a link below in the video description, not only for all the timestamps in this video, but also to the TryHackMe official Discord, as well as the DarkSec Discord. If you like this content, follow me on Twitter, subscribe to me on YouTube, and I will see you guys next time.